Happy Chinese New Year. Could you please turn on the camera as said last time? We're here. Okay, for the rest of you, could you please open the camera and let me know you're here. Aside from this lesson, I will request you guys to turn on the camera. And while we are waiting, check class practice 14.3. Last time I asked you guys to do it at home, to talk something more about the ionic equations of direct acid. It gives you a foundation of what is happening. What happens to the presence of what is meant by what is the major chemical species which cause acidic property? You may find that. I'll spend some time now. Last time I just asked you guys to read through this one, okay? And I asked you guys to do this, right? Class practice 14.3. Just make sure that you have done that. Not, please do it now. Now, for the time being, I would like to check your attendance. As I said before, page 13, class practice 14.3. Now, as I said last time, could you please open the camera for those who can with the classroom? Please open the camera and let me know you're here. Màu đen gì, trà hy gì, không sao. Màu đen重，
先生，我可唔可以轉一轉個 device 啊？
好啊，好啊。陣間previously, now let's have a quick practice. You want to know your do you have the camera?
我下次會有，我下次會有。
Yes， 朱家賢同俊傑、曾海燕、鍾朗燕。Yeah, you have it. 劉軒族。
咩啊？上
？One of them is missing. Just double check who are those. So welcome all of you. And because of unstable pandemic situation, we do think that we will need to turn to Zoom for some time. So what can we do is that just stay calm and life must continue. Also, this is what I would like to remind all of you, right? So as I said before, please make sure you have turned on the camera.
錢 Sir，我而家換緊電腦去開 camera，可唔可以等我？
好啊，好，你陣間再入啦。曾海天 can you manage to have a camera with you?
點解我電腦冇 camera？
You have to solve it anyway. You have any difficulties, please PM me after the lesson. Now, so question 1, I would like to invite some students here to have a try on that. Zakahim, transcribe the following chemical equation to ionic equation. Zakahim, this time we are going to use to change it as ionic equation.
最尾應該係 Fe solid 再加兩個 hydrogen ion aqueous solution aqueous 嘅，跟住會出到 iron 2 plus aqueous 同埋 H2 gas.
Yes, that's right. Very good. So the spectator ion is sulfate ion. So recall your memory about how to write down the ionic equations. Now, and it is indeed the same as what we have just mentioned about acid. Whatever acid we are having, there is one common ion. It is hydrogen ion. Okay, so you may find the hydrogen ion, of course, play a role in the reaction. So that's why you may see hydrogen ion here. How about B? Thank you. How about B? Can I have Tam Jian? Hi, Tam Jian. Could you please tell me how to get approach to 1B? Now, two issues. First one, do you which in order to get approach to the ionic equation, you need to split those substances in AQ, right? So do you have are there any spectator ion?
Chloride.
Yes, chloride ion is a spectator ion. So these two can be carried off, okay? So finally, this chloride ion is a spectator ion. So what is left behind is to just write down the whole thing, but skip hydrogen ion. Okay, remember the spectator ion does not involve in the chemical reaction. So the way to write down ionic equation is to show the major chemical species inside the chemical reactions. Is that clear? Now?
Okay.
Yeah, thank you. And how about question 2? Lưu Minh Châu.
Yeah.
Lưu Minh Châu, where are you?
Here.
Yes, tell me you are going to write down the ionic equation for the reaction involved. So what is it about? You are going to add a few drops of lemon juice into sodium carbonate powder. Now, if you are asked to write down the major acid responsible, right, for this reaction, you may find it difficult, right? But I said before, whenever you write down Ionic equation, right, for the reaction between dilute acid, there is one common ion. What is that? Once you know it, the whole case can be very simple.
Hydrogen ion.
Yes, hydrogen ion. Yes, that's right, hydrogen ion. So the way to solve it is by write down hydrogen ion. And how about sodium carbonate powder? So you may write down sodium carbonate powder. 2 hydrogenized to form what?
2 sodium ion
Yep, and then
plus water plus carbon dioxide.
with a mole ratio 2:1. Okay, so of course somebody would also write down this. Okay, like this. So it is also possible. Why? Because for the sodium carbonate, it is water soluble. So as you may heard of some other saying about having this equation as an Ionic equation. Now, however, I would like to remind you this part. For this equation, right? This is the only equation for 1B, but we cannot use this equation, the one in the bracket, to replace this. Do you know why? Calcium carbonate is not water soluble. Is that clear? Calcium carbonate is not water soluble, so we can never write the one in bracket to replace 1B. But for question 2, we have got 2 answers. Either answer they are acceptable because sodium carbonate is water soluble. So it does make sense to say that first of all, sodium carbonate dissolve in water to form carbonate ion, while the carbonate ion react with hydrogen ion to cause effervescence. The colorless gas bubbles is CO2 and H2O. Okay, is that clear? Any questions? Do we have a chance of asking you to write down the true formula of the acid in the lemon juice? How about full equation? 有冇㗎？我會唔會走嚟問你㗎？譬如 lemon juice，可唔可以寫條 chemical equation 咧？咁樣 Will they have a chance?
I think if it is asked, the formula will be given.
Yes, that's right. So lemon juice, it depends on what acid you are talking about. You have got 2 common acid that is found in lemon juice. The major one is citric acid. The other one, citric acid, 檸檬酸. The other one is ascorbic acid. This is vitamin C. So if they really ask for writing the chemical equation, but not Ionic equation, the citric acid, the formula of it will be given. Don't worry, this will be given. So, but once you'll be given like this, how will you get approach to the problem? Huh? That is another issue. Just like what Clement Jen has been suggested, citric acid. Have I written this? If not, you may check on the web as well. How about this part? If I ask you to write down the citric acid, the formula of it, how can we get approach to the problem? How will you write down the chemical equation? Citric acid. This is hydroxide acid. Citric acid. Let me check. Well, all of you, please check it as well. Citric acid. Very strange structure. This one. Can you see that? You may find such. But what is the turning point? Last time I just tell you. What is that? It is carbon. It's carbon. So remember, keep this in mind. All those turning point, it is just carbon. So you may have got some COOH group, right? It tells you basicity of the acid. What is the basicity of the acid? Wang Zihin, what is the basicity of the acid? Sorry, could you please say it again?
係咪嗰個 number of hydrogen ion？
Yes, so according to this example of that acid, so there are so many hydrogen ion, right? Hydrogen atom. Would all hydrogen atom be ionized? Just spot for me. What is the basicity? Yes, the answer is correct. It's 3. Okay. I just see some people who just write it down. The answer for me is 3. It's a tri-basic acid. While the H of the COOH group, we call it carboxyl group. That hydrogen atom can be ionized. So you go back to this. If you are asked to really write for the chemical equation for the citric acid and sodium carbonate. So what is the equation? Please try. Do you know how to write down the answer? So this COOH and then OH. We have got CH2, COOH, and then we have got also that CH2, but this time is COOH. Now, because it is in terminal, I would like to write it in reverse. Okay, so but they are talking about the same thing. That COOH is referring to the presence of the carboxyl group, while the H in the COOH can be ionized. So we call that tri-basic acid. So what will happen if I add it as sodium carbonate powder? So what can it be? Again, salt, carbon dioxide, and water, right? So what is the name of the salt? What's the name of the salt? Hey, do you know what's that? What is that salt? What is the name of salt?
Sodium citrate.
Yes, sodium citrate. So, how to write down the formula of citrate? Citrate. Yes, it's sodium citrate.
Remove all of the ionizable hydrogen atoms and then just give just count the charge of the ion, and then you just balance it with the positive the one positive charge of sodium atom.
Okay, so what is that COO? What is the charge for this? I just highlighted, right? This part, these 3. What's the charge? After
-1.
move for hydrogen ion, it becomes negative. Okay, negative. Okay, is that clear? So we write that like this way, and what is left behind is to write down the cation, sodium citrate. Okay, we have got Na+. So the ionic part, so this the anion is a very big anion. Could you say that? A very big anion. This is the big anion. While the big ion, we have got 3 parts, which is negative. While the negative, of course, they will be attracted by cation. The cation is sodium ion. This sodium citrate. How about the other product is carbon dioxide and water. So write it down as carbon dioxide and water. So my question is how to balance that equation. You're going to balance it. What is the mole ratio?黃正通。
I don't know.
Now recall your memory about the balancing chemical equation. The approach is MiNOH. So the first chemical species to be considered as sodium. That is the only metal part, right? So you take a look on the reactant side. Reactant side, how many sodium are there? It's just 2, right? Can you see that? It's 2. But for the product part, it's now becoming 3. In order to balance the whole thing, you need to think of LCM, lowest common multiple, right? So in order to balance it. So of course the answer is the before this part is 3. How about the whole thing? Whole thing here it is 2. Is that clear? By doing so, you may have 6 sodium ion. But once I make such, what will happen is the citric acid, the reactant. We have got how many citrates are there? We have got 1 citrate times 2. So on top, what should be added? You make the whole citric acid as times what? Now the parts of these two, they are very similar, right? So once I write it as 2 on the product side, how about reactant? You are going to do the same. Leaving behind is for carbon dioxide and water. How many? Clement Chan.
1, 1.
1, 1. Any other answers? How many carbonate are there?
3.
3. So for carbon dioxide, it is
3.
It's also 3. So how would you know that? Because it is just carbonate react with acid to form what carbon dioxide and water, right? So whenever you mark it as 3 here, this one must be 3. Is that clear? Now we do the same thing. How about the H2O? H2O part is quite difficult, right? Because you really count the O part, there is quite confusing. We've got so many O here. But you may think it as hydrogen ion. Hydrogen ion. How many hydrogen ions is on the left-hand side? And you are doing to do the same by writing this, and you will know what is the final stoichiometric coefficient. The number before H2O. How many? The whole thing is 3H, right? Times 2, altogether 6. For 1 H2O here, I've got 2H, right? So the number before H2O is
3.
Yes, this 3. Now, I would like to tell you my approach, right? You are going to balance the metal part, sodium ion, I balance citrate ion. Do you realize? And then for non-metal, I check for carbon. And leaving behind for O and H, this time I check for H only because O is rather confusing to me. Any questions so far? Okay. difficult？
有啲唔係好明點樣 balance 嗰個。
照數啫嘛，真係照數啫喎。個問題係一開始要點啊 ？First of all，balance the metal part. Metal is sodium. Now you do the same thing. How do I know the answer is this? Is indeed go back to the Ionic equation. Is carbonate react with acid to form CO2 and H2O? I do the same thing. So what would you find here in when you balance the Ionic equation? Is 3 CO3 2 minus plus 6 hydrogen ion to form what? 3 CO2 and 3 H2O. Do you realize? Of course, this one you have to go back to this. The whole thing we have got 3, 6, 3, 3. It's not a simplest whole number ratio. I change it back to 1, 2, 1, 1. But how do I rapidly know that it is 3 and 6? Now I start from this, okay? I start from this, and later on, because I know that acid being tribasic, so which means that for each acid molecule, we have got 3 hydrogen atom that can be ionized. And because the whole equation is double, so altogether, you are going to tackle 6 hydrogen ion instead. Okay, so that's why each tribase acid, we have got 3 hydrogen atoms to be ionized, which means that the acid together with the salt, that must be in 2:2 mole ratio. While leaving behind for carbonate, you must have the portions 3, okay, in order to balance the whole thing. Because we have got 3 carbonate, that C will finally go to CO2. So because of that, it limits the number of CO2. I make it as 3. And as said before, we are this equation dealing with 6 hydrogen ion. While the 6 hydrogen ion, they will finally go as water, while 1 H2O contains 2 hydrogen atoms. So that's why the number before H2O must be 3. Can you get that? So it doesn't matter. It doesn't matter whether or not the structure, whatever structure that you'll be given. As long as you know the Ionic equation and you are going to multiply it corresponding to the basicity of an acid, you can solve the problem. So what is the hidden message? Next time I may ask you some other different combination. It's not citric acid, it can be other acid, just like oxalic acid. You do the same. Okay? It also comes from this Ionic equation. Whatever ratio it is, it's just a multiple. Is that clear? 你明我講咩嘢？因為係唔明啊，你好出聲啊！即係我最尾都係睇翻條硬啲 equation， 諗翻轉頭啫嘛，係嘛 ？For that Ionic equation, the mole ratio has been kept fixed 1, 2, 1, 1. I start from this. 跟到嘛？見到 ？OK？ 有咩問？好 puzzle 啊！你哋樣，喂唔明好出聲喎，大佬，跟到未
OK，
知啊，知我講乜？知我講乜？好，係啊，好迷霧啊！你哋呢樣好驚喎。好，掂唔掂？掂啦，掂我飛咯喎，去第二度咯喎。
阿 Sir， 可唔可以用中文講一次？
用中文講一次？用中文講一次，咪就係由條離子方程式嗰度嘅一個倍數咯。因為離子方程式話咗俾你聽，碳酸根離子同氫離子兩個嘅反應，佢哋摩爾比例係1:2啊嘛，係嘛？咁所以而每一個檸檬酸咧， 個鹽基度係3啊嘛，咁冇理由，咁我哋又每一次都係講緊個倍數係一個雙數嚟噶嘛，所以一開始檸檬酸一定要係第一嗰個氫離子我可以做得到，繼續得到咯。咁所以第一樣嘢，檸檬酸就一定係乘2咯。第二，你有冇留意到咧？我喺呢一度嗰個方程式上邊咧，我全部已經用咗紅色筆啦、綠色筆同埋藍色筆咧，我揀低晒佢唔同類型嘅物質嘅。其實咧，嗰啲物質咧，最後都係等於翻佢哋嘅離子方程式嘅啫。因為喺呢條式入邊咧，藍色筆嗰個 citrate 咧，即係講緊嘅檸檬酸根離子咧，係呢一個嘅叫做 Surfactant 嚟嘅。咁所以咧，你會見到咧就係嗰個所謂嘅 H 咧，根本呢度就係等於6個 H 㗎，六個 H 定嘅，得唔得？而我哋講緊嘅 carbonate 咧 ，carbonate 嗰度咧就係等於咩咧？就係等於呢度，就係等於而家我哋綠色筆嗰啲啦，得唔得？咁我而家
即係有兩邊綠色筆嘅，即係上下兩邊都 count 嘅。
上下兩邊都 count， 梗係要 count 啦。左手邊上下邊係咩嚟㗎？上邊係反應物嚟，生反應物嚟㗎嘛，下邊係生成物啊嘛，係嘛？反應物上面反應物嘅數要等於翻生成物嘅數㗎嘛，咪物質守恒定律咯。盡可能
OK，
盡可能講咗中文㗎啦。OK， 掂你
OK。
咁所以個 citrate ion 你根本你唔需要驚佢㗎。你而家其實成件事你覺得最恐怖嘅地方就係嗰個 citrate ion 一個大型龐然大物喺度嚇住你啫嘛。但係如果我用藍色筆嗰個概念，我揀低咗佢，根本係一嚿嚿咁一齊倍大縮細咯。喺呢個 case 嚟講，一個檸檬酸係鹽基度係3，而每一個我哋寫 Ionic equation 咧，嗰個 hydrogen ion 點都係2嗰陣時，個答案一定要係6咯，6個 H 咯，個 H 定咯，係咪啊？你先可以做得到。咁所以 citrate X 一定乘2咯，明唔明？咁好啦 ，carbon 嚟變 carbon dioxide 嗰個 C 咧係同一個 C 嚟嘅。咁我數其他嘅 C 係唔需要數嘅，因為其他嘅 C 咧喺呢個反應入邊係冇反應噶嘛。頭先講咗 Surfactant 啊嘛，所以你根本可以查咗，你可以唔需要理會佢。總之一齊乘咗2，你就搞掂咗一大部分噶啦，明唔明？諗得到？即係最尾我真係數呢個數啫嘛，就係數呢個數啫嘛。CO2 CO3 2 minus hydrogen ion CO2 H2O 要 balance 呢條數嘅嘛都係。OK， 得嗎？嗱，如果 OK 嘅話咧，係咪得先？得嘅話就係去到 alkaline 嗰度。Now for alkali, this is the term you know it in Form 2, right? So this is the chemical in which it react with acid to form salt and water only. Now, so please underline the term only. So only by saying this term only, we will tell this the reaction neutralization. Acid plus alkali to form salt and water. So you know it in Form 2, yes. But in Form 4, we will add one more chemical, which is we call it a base, which also causes neutralization. The only difference between alkali and base is that not all alkali must be water soluble, but base, some can, some cannot. So remember, it is it seems like a set subset logic. Okay, alkalis, bases also include something which is water insoluble and something water soluble. So alkaline is a very special name to describe water soluble base. Do you understand? So that's why we have got the following example, it comes to a concern how to memorize which one is called as a alkali, which one cannot, and we are forced to say it as base. So you may find the following. In short, any pattern that you may find. Okay, you see that? It's a group 1 hydroxide. All group 1 salts, they are water soluble. Don't need to mention it is hydroxide. So we will call that a alkali. Of course, you can also tell it as a base. Okay, you get my point? So can you see the word most solid oxide and hydroxide, they are base. Do you see that? So how about group 1 group 1 oxide? Now group 1 oxide is very special. It will react with water to form group 1 hydroxide. While you know that group 1 hydroxide is water soluble. So group 1 oxide, indeed, it is equal to its hydroxide when you talk about when reacting with water. How about group 2? Group 2 for magnesium hydroxide. This is water insoluble, but for calcium, another group 2 hydroxide is water soluble. How about some others? But it is slightly soluble. Slightly soluble. That's why lime water you may find sometimes it is a little bit milky. Now you check the periodic table. How about strontium, barium hydroxide? For strontium, barium hydroxide, it is also called it as an alkali. It's a water soluble base. For all other hydroxides, which is non-group 1, all of you please mark it down. We will say that water insoluble. Example include magnesium hydroxide, iron 3 hydroxide, iron 2 hydroxide, lead 2 hydroxide, etc. Aluminium hydroxide also. Okay. How about oxide? As said before, group 1 oxide, it will react with water to form hydroxide. So it is not an insoluble base. Group 2, MgO is not water soluble. How about calcium oxide? Is it water insoluble? No. Calcium oxide can react with water to form slick lime. Could you still remember? Calcium hydroxide. So calcium oxide is not an insoluble base. For all other oxide, again, non-group 1 oxide, mostly we call that insoluble base, except calcium oxide. You may think it like strontium oxide, barium oxide also, but not magnesium oxide. Can you get my point? While for group 1 oxide, it is an alkali because it will finally react to form its own hydroxide, which is water soluble. Now, go back to solubility rule again. So that's why it's quite strange to have oxide as solubility rule. For some oxide that said is mostly water insoluble, but some of them they will write down reaction. 你記唔記得你個畫個 solubility rule 咧會有呢樣嘢嘅 ？Whenever we have got column for oxide, we have got reaction. Why? Because there is a reaction. There's a general equation. Oxide react with water to form hydroxide. Now, this is the case that you know it in form 3. Now, I miss out one important example here. This is the one, ammonia, a very strange chemical in which when you compare it with the others, ammonia, you may find there is no metal containing, while for the others, they are metal containing. Can you see that? So in order to describe its action with water, it's a little bit different. If you want to talk about the all other metal containing alkali, hydroxide, we have what they put in water, they would have the ions become mobile. We will call this or dissolves, okay, or dissociate. But we cannot say it as ionize. Why? Because it is already ionic compound. It's already ionic compound. The purpose of having water is to make the ions become mobile. So the nature of the chemical is still ionic compound. So we would not saying the process of turning something not ions to ions. But that is the case for ammonia. Ammonia itself is molecule. It will react with water to form ions. So that's why if you write down this one, I would express it as ionization. While the ionization, when you see the double arrow here, which means that it's not 100%, slight ionization. Not 100%, do you mean the 90%? No, very slight. Only a few percent of the ammonia molecule that can be ionized to form ammonium ion and hydroxide ion. Can you see that? It's only a small amount of hydroxide ion that are formed. So most of the ammonia molecule, ammonia, it will be stay as molecular form. While itself being volatile, when you open the bottle of those alkali, only this will have got a smell. We have got a smell. We have got a pungent smell. That pungent smell seems like while you go to the male's toilet and you can smell very often. 啲尿嘅鴨味 smells like urine. But for some other alkali, once you open the bottle, you attempt to smell it, no smell. Why do you have no smell? It's ionic compound. One of the ions that held together by strong ionic bond, so it's quite difficult for them to evaporate. So those ions cannot reach your nose so easily. So you cannot smell it. But not for ammonia. You understand? How about acid? How about acid? Acid is another case. If most organic acid being molecular form, you open a bottle and you can smell, just like vinegar. Why? Because the molecule can evaporate so easily, so that you can reach your nose. But not all acid can be smelled. For example, HCl. No, because HCl vapor is highly corrosive. So please do not smell them, especially corn HCl. Just to remember why we do the flame test, where you open the bottle, some white fumes that come out. It's rather nasty. So never smell the HCl vapor. It's highly corrosive. Any questions? So in short, I just tell you something about alkaline and base. First of all alkaline can set as a base. So you may see that a water-soluble base. Once I dissolve in water, it will release hydroxide ion as a common ion. So no matter it is NaOH, KOH, of course you may have hydroxide ion containing, but also ammonia. The ammonia, they will also contain in aqueous solution, they will contain hydroxide ion. but the amount is rather slight, small amounts because the degree of ionization is low. The common ion is what? Hydroxide. Questions? So you are going to get to know something more about alkali. About that uses. What is the uses of alkaline base? Now, usually, you can separate. You can use alkaline as mainly for cleaning in household. So you may find that glass cleanser, drain cleanser is for cleaning. Especially, you are going to deal with very good for dealing with oil blockage. You use alkaline. So it is one thing, you may find sodium hydroxide solution. And also you may get this one with the red cap, white bottle with some white pellet inside, white solid, right? You sell it for $10 for 3 bottles before Chinese New Year. You know it, you go to 五金鋪. Do you know what's that? What is that?
五金店咯，嗰啲賣鐵嘅。
So what is that? Tell me what is that bottle? If you go to the shopkeeper, ask for this. I would like to buy 3 bottles of caustic soda. What is that in Chinese?
No.
No? 咩 no 咩啊
No, I don't know.
You don't know. 過時的。聽過未啊？過時的。What is the use of caustic soda? It is used to pour it into the drainage pipe. Okay, in case there is blockage. Why? Now, especially it would really help while you talk about the drainage pipe inside the kitchen. Now, very often, especially in winter time, you may need to cook, right? Of course, with the sauce which is too oily, some people would just directly pour it into the drainage pipe, right? Somebody will have such habit, right? But that oil will got stuck into the inner layer of the drainage pipe and will make a blockage. Just like the people who have high blood pressure, some oil that get that blockage in the blood vessels. 好似咁嘅. But of course, for human, while we are going to remove it by using controlling your diet, doing exercise. But for the drainage pipe, it's easy. It can be using some mechanical method or chemical method. For mechanical method, it's done by what? It's done by pumping. Okay, it's by pumping through the oil pipe. So while you say some saying in the TV, in the advertisement, right, which is posted on the street lamp, 通渠王，有冇見過啊？通渠王嗰啲咧，咁啲人做啲咩咧 ？While you go to the place, they would have a pump of high pressure to pump away those oil. Method 1. Method 2, you can solve it by your own. Is by using caustic soda. It's a solid sodium hydroxide. I pour it into the oil drainage pipe and wait for what? Wait for the reaction. The reaction between the NaOH and oil to form something water soluble. While what is that water soluble substance? It is just soap. 就係我啲番梘啦。So it can be easily washed away. 包括 oil, we are referring to cooking oil, right? But not crude oil, right? Of course, in order to make the reaction happen, in order to get in contact with the oil and the NaOH, you may use hot water for help. But NaOH, once it dissolves in water, it will also generate heat. So what will happen? There is one disadvantage, one drawback of using caustic soda in the drainage pipe. 你知唔知會有咩問題？ If it is too hot, what will happen to the pipe? Do you know the material of making the pipe? Plastic. Do you know what plastic is? We call it PVC. It's a type of plastic. So so if you add too much drainage cleaner to the drainage pipe, you may yes, you may heard of some a saying about changing in shape, okay, of the drainage pipe. So you have to handle this with great care. What else? Ammonia here, and also the ammonia is also alkaline, which will help remove the oil as well, in order to clean the glass, especially for the window. Besides ammonia, I would see the word surfactant. Have you ever heard of that term? Surfactant. 表面活性劑. It helps reduce the surface tension of water. 水嘅表面張力啊 such that the water droplet, once they stay on the window, they will drip away so easily. Now, for example, the window is here, right? They will drip away so easily. Why? Because it will say an effect, we call it wetting. Wetting. So wetting, which means the water droplet will no longer stay as a droplet. Okay, so we like this. That's why whenever you see the word surfactant, you may see the water. There will be no water fogging, anti-fogging. 防下氣啊 So in order to clean the windows always. So that's why it's very strange. Whenever you see the windows which is cleaned with window cleanser, whenever you stay for the raining, but you may see the water is very slippery. They will flow down through the windows by gravity, and they will leave away. Do you realize? Very different. For those who wear glasses, who like to apply some or wearing swimming goggles, for example, somebody will spray some surfactant, which will help make an anti-fogging effect. How about sodium calcium hydroxide, slick lime? Because it can react with acid, it can help reduce the acidity of soil. Now, because I said before, that the acid being the soil being too acidic is no good to the agriculture. Okay, it's no good to the plants. So it's done by having calcium hydroxide. Of course, you can also add calcium carbonate. Also, is okay. So that's why people would spray some eggshells into the plant, just above the soil, right? It is a free fertilizer at home if you are going to do such. Last but not least is here, anti-acid tablets. This comes from the word anti-acid. Anti-acid. 抗酸劑 抗酸劑 antioxidant. Now why is the I letter I omitted? It's because I and A they are both vowels and they will stick together. Whenever you see vowels, the vowels will help you pronounce the word. While I and A is quite difficult to pronounce the two vowel words altogether, so that I will be skipped. So that's why usually while you see the antioxidant tablet, they write down antioxidant tablet. Something about English. While the antioxidant tablet, we have got two antioxidant tablets. The one which have a small pills, okay, which eat together with anti-inflammatory drugs. It is not that one. This one, it is treat for another thing. It's to treat what? Is treat excessive stomach acid.
咪胃酸倒流
yes, maybe, or too much acid, especially it will be no good to you, right? It will give you some uncomfortable feeling. So that antioxidant tablet is very strange. It is in terms of very big tablet. You cannot just eat it. You're going to chew it. And then by doing so, you can break down the small pieces. Okay, it allows what? 知唔知道點解啲胃藥有一種胃藥要咁樣㗎？要嚼㗎？呢一隻咧就係咩咧？呢隻就係治標嘅方法啦。如果你要有一隻胃藥係大大粒嘅，咁你會點㗎？ They will ask you to chew it before you swallow. By doing so, you can increase the surface area of contact with plastic juice, so as to lessen the feeling of uncomfortable feeling because of too excessive acid inside the stomach. The question comes, Mr. Chin would like to ask you, what is the acid found inside the stomach? Do you study biology? Biology. You don't study biology?
No.
Just treat it as a common knowledge. Anyone who can help?
HCl.
HCl, yes, that's right. Hydrochloric acid. So it's the stomach is of HCl. You may I know some of you may have an experience of vomiting. Suddenly your stomach feels uncomfortable, you want to vomit. While you after you vomit, right? You may feel here it's very sour. Right? It's because of stomach acid get mixed with food. Now, what is the chemical to be responsible for that? Indeed, we have got aluminium hydroxide and magnesium hydroxide as the active ingredient. 主要有效成分 active ingredient. Now, not all chemical, not all mass in the tablet will contribute to make that effect. Only those active ingredients will help. Now, aluminium hydroxide, magnesium hydroxide is water insoluble. So, the only reaction between the antioxidant tablet with the acid is by the surface. Do you see why? I write down, I want to increase the surface area of contact. This is what you have to do. 所以胃片咧就唔可以唔嚼吞落去，都得嘅，不過唔係最快咁醫治到胃酸過多嘅問題。Why? Because for the reaction to occur, it must have a contact with the tablet and the acid. If you want to make it more efficient, if you make the effect faster, you are going to increase the surface area by chewing. Do you understand? 呢個係最簡單嘅。咁仲有一隻藥咧，細細粒嘅，嗰啲係另外一隻啦，就唔呢藥唔係呢隻就唔係咁樣 deal with 胃酸過多嘅。另外一隻咧就治本嘅方法係咩咧？叫胃酸抑制劑。OK，the gastric acid inhibitor. It is something to deal with the stomach lining. To stop the secretion, to slow down the secretion. It's another principle. So go back to this. It's very enough for chemistry student. Can you write down the equations? Can you write down equations? Aluminium hydroxide, magnesium hydroxide, together with HCl. So what is the reaction? What will be the form? There.
Aluminium chloride.
Yes, aluminium chloride and
H2O.
Yeah, with a mole ratio.
Mole ratio 2H2O and 唔係，等陣先，我揀下先。
Now you use the same concept, right? Same logic. You spot the word salt. Al.
3HCl and 3H2O.
Or 3HCl. Yes, that's right. So you use the similar logic, right? Is 3 HCl to form AlHCl3 balanced. Leaving behind is for H here. H. Sorry. It's H here. 2 and hydroxide, 3 hydroxide. What H it is, you may relate as hydrogen ion, right? So you have got H2O. For one H2O to be formed, it needs the help of 1 hydrogen ion and 1 hydroxide. So here comes 3 and 3 on the left hand side. So of course this one's 3. Now believe it or not, you do the same tricks by doing magnesium hydroxide with HCl to form what? Magnesium chloride together with water. So I do the same thing. MgCl2 is a salt form. And the salt here, we have got the 2 here. Again, check hydrogen ion and hydroxide. 2 hydroxide and 2 hydrogen ion, of course, is 2 water. Do you understand? Now, when you're going to balance the equation, there are some hidden patterns, but for you to realize and for you to discover. I do hope that by doing so, you may know more about the chemistry of this. Any questions so far? Now we covered quite a lot on the on introduction of alkali and tell you the difference between the base and alkali. Now indeed, all alkalines, they are bases, but it is a very special base because it is water soluble. And I give you some examples. Besides memorizing those examples, we have given you some generalization. For group one, no matter it's oxide and hydroxide, it's water soluble. Okay, they will both form it as a hydroxide, it is a alkaline. But for group 2 for exchange, for magnesium oxide, magnesium hydroxide, it is water insoluble. But for calcium oxide, calcium hydroxide, strontium oxide, strontium hydroxide, barium oxide, barium hydroxide, right? You may find that it is water soluble. in which oxide will react with water to form hydroxide. And also ammonia. All those mentioned, they are just alkaline. But for the other non-group 1 oxide or non-group 1 hydroxide, other than those other exception mentions, we generally call it as water insoluble. The role to play is to react with acid to form solid water. Okay, so our common ion is hydroxide ion. Okay, is it clear? So before I end up the lecture today, I would like to give you this one, ammonia. How can we produce ammonia? It's by bubbling ammonia gas into water, like this setup. Okay, and this setup is very strange when you compare with this. You directly bubble it into water. Why? What is the purpose of inverted filler funnel? Is to increase the area of contact with between water and the gas, so that the sucking back will be lessened. So this is a very special arrangement for that. Now, of course, if you deal with some other gases, just like HCl, is also okay. Why? As said before, whenever you deal with acid, whenever you deal with the gas which is highly water soluble, if you want to make it in the aqueous state, never just bubble it like this one. Okay, otherwise you will have sucking back. Why we have got a sucking back? You take a look on that. Here. What does it mean by the greater surface area, smaller surface area? And it's not just surface area, it's because of the volume that will occupy. I would like to mention about volume will occupy. For example, if you're going to dissolve the ammonia gas using that certain volume like this, okay, for this part you use the delivery tube only, that may occupy up to here for the same volume of water suck up. So that's why having a inverted filter funnel would really help. Now, why do I say so? It will help you explain something. I would like to give you a video shortly. Now, please watch it and tell me the principle of fountain experiments. We call that fountain experiments. I would like you guys to watch the video after the lesson today, and we would like to discuss it in the next lesson. I will show you the web link of fountain experiments in the WhatsApp group. Okay, and please go home and try to read it and tell me the principle. Okay, is that clear? Now, before you leave, I would like to tell you something to ask you. Let me know whether or not you understand or not any difficult part, and tell me the level of understanding. I will share with you the web link first. Fountain experiments. About the others. I'll just give you a link. Please watch it and tell me anyone the reasons for observations. That is a fountain experiment. Okay. Alkaline base 談詞人 balance what? I see 梁君如 say balance equation again.
係啊。
Okay, so don't worry, if you find it difficult to follow, we will continue next lesson. I would seriously consider having some afternoon section, right? Supplementary lesson section with you, such that you would get to know more about that. How about next week? Shall we have one? 都要㗎啦，唔緊要，我哋慢慢嚟呢度，你一定要搞得清楚呢度，如果唔係咧，你搞唔掂。
OK，
Okay, and be prepared to have some arrangement. 2 weeks later, we have got a student teacher that will come to you. He will deliver the lesson in Zoom. So he will start over the topic in the next 2 chapters. Stay tuned. Okay, and see you guys next week. Bye bye.
Bye.
Bye bye。
拜拜。
拜拜。
拜拜。